Welcome, everyone. My name is James. I work for a company called GuardSquare, and today I'm going to talk to you about client-side security. I'm going to talk to you about client-side security at a very high level. It's not going to be a technical topic. I'm going to talk to you more about the more about the why and the when rather than the how. So to get started, let's paint a picture of maybe a security high architecture of your app at an extremely high level. So let's think about the server side. Normally, this is a very controlled environment. You have control over your servers. You have firewalls. You have tools, auditing, login, log managers, these kind of things. It's a kind of heaven environment, a Garden of Eden in the security architecture here, because you have full control. But then on the opposite side is the client app. So the client app, you don't have control over where it's running. So you distribute your app in some kind of store or maybe maybe outside of stores, but somehow you distribute your app to your users, but then you don't have control over the devices that the users are running your app on. So you don't know if your app is running on a phone, an emulator, a toaster, a fridge. You have no control there. The user can do whatever they want with your app once they get their hands on it. So that's the complete opposite of the server side, where you have the full control. And let's also not forget about the user of the app. So often we think about server-side security, maybe client-side security, but we also need to put the user in the picture here. So there's often a balance to be made between the UX and the security of your app and of your service, your application in general, including the server side, the client side, and we should also add the user in there. So that user needs to be able to use your app. If you have an app which doesn't do anything, then that's probably the most secure app. It doesn't do anything, so there's nothing can go wrong, but then that's not good for the user. The user can't use your service. And normally your app is often the gateway into your service for a user. So the user is using your app to consume your service somehow or to enter data into your service. And they're also using features potentially like accessibility, text-to-speech, these kind of things. So sometimes then you have to think about that trade-off for the user. Like the user has to have a good experience of using your app, but you also need to protect yourselves, your company, your application, your service. And so that's why we need to think of the user as part of the security architecture of your app as well. So the user is potentially entering sensitive information into your app, and it's often the only way to interact with your service. And then it doesn't matter even if your app is the thinnest of apps. It could just be a web view, for example, but the user is still entering their sensitive information even through that thin app. So on your server side, you have all of these protections, you have firewalls, you have monitoring systems, and then on the client side, your user is entering sensitive information into a device which you have no control over. So you might think, well, does client-side security really matter for real-world apps? I'm going to show you some examples of where it does matter and why some companies will put a lot of effort into this. I'm going to show you some examples which are from different areas, different industries, and maybe then that should make it relatable to quite a lot of you here. So the first scenario, the first story that I want to talk to you about is app modding. So this is taking an application, original application, changing it somehow, and then someone distributes this modified application. So this is normally to improve the app for some reason. But improve it for who? It improves it for the user maybe, but it's not improved from the point of view of you guys, the app developers. But why would they want to do that? Well, the improvements could be, for example, the removing ads. So then the obvious effect is monetization. So if you rely on the monetization of selling your app or advertising revenue, and then users can get an ad-free version or a free version of your app instead of the paid version or instead of the version with adverts, then that's better for the user, but it's not better for you. Some modded apps could also come with extra features, and some could be with features unlocked. So here we're talking about taking original apps, somehow modifying them. The reason that the user wants to use these modified apps is because, in their view, the app is better. From the point of view of the developer, that's not a good thing, obviously. So some examples of apps in real world which are modded apps in some way. The size doesn't really matter here. So there are these huge apps which are downloaded billions of times, which you can find modded for some reason. So the YouTube app, for example, there is some modded version available out there on these dodgy app stores that you can find, which is modded, so you don't need to watch ads. But there are also much smaller apps that have only thousands of downloads. So it doesn't mean that if you're smaller, that you fly under the radar, no one cares about your app. For some people, if they can get a better deal, in this case, yeah, the app is free, why would they use your original app if they can easily get the modded version? And yeah, again, the size here is kind of irrelevant. The point is that in the eyes of the user of the app, in some way it's better for them to use the modded app rather than the original app. Second scenario that I want to talk about is in the fintech world, namely crypto. In this case, we have a modded app again, but the scenario is different because in this scenario, the user did not mean to use this new crypto app. So say that you make a crypto app and some bad actor, for some reason, they mod your app and produce a version of your app which works identically. And then somehow there is some social engineering attack which leads in the end to the user installing the modded version of the app rather than the original app. So in this case, from the server point of view, the app looks the same, the API calls are all the same. So it's difficult to tell from the server side that the app is modded. But then at some point, the attacker could switch the API calls, they could change the behavior in the app. The user has installed this app, they don't know that this app is potentially installed. They think they're using your original app because they got this through some kind of social engineering. They clicked on some link in some spam email or something like that. So this is another case of modding, but the scenario is different because, but the scenario is different because the user here didn't mean to install the app, and it's not better in that way for them. And then for the developer of the app, this is quite bad because they can't necessarily then say which apps are modded, which apps are not, because the app works the same as the original app until the point that the attacker wants to maybe change the behavior of the app and make it do something different. The third story that I want to talk about is around multi-user applications. So for example, with cheating in video games. So say you have a video game app, a lot of the logic would happen maybe on the client side. And then some people like to win at games. So, if you can find a modded version of your app, which, for example, allows you to see through walls in a shooter app so that you can see who who is hidden behind the wall. Maybe then that gives you an advantage over other players. This applies to gaming apps, but also other apps that are based on, for example, GPS. You could spoof the GPS, make it appear that you are somewhere where you're not. And in this case, the damage is to you as the developer of the game. It doesn't make your app want to be playable by the majority of your users, because you have a few people who have this big advantage over the majority of your users. There are these few people that don't care about how they win. They just want to win, so they don't mind cheating. And in that case, then there are these other people who do want to play your app. They do want to pay for your app. They do want to play fairly, but it's not fair for them. This is different from the other scenarios as well, because in this case, these apps could be the real apps. They don't necessarily have to be modded apps. So these apps could be downloaded from the official Google Play Store, from the Amazon Store, etc. But then at runtime, we can change the behavior of the app. So if your app is not protected well, the behavior of your app could be changed, and this can lead to things like cheating in games. So that's some scenarios about why you might need protection in your app. And then, obviously, there's a bit of nuance there. Do you need protection or not? Hopefully, that gives you some ideas of some existing examples of where you might need protection. But what does it mean to protect an app? So a lot of you, probably most of you here, are Android developers. You've probably heard of ProGuard R8, Flutter, obfuscations. So you might think, well, okay, I set Minify enable to true in my build.gradle file. Everything should be okay. So I'm going to show you a bit of code, and it's maybe a difficult question. I want you to think really hard about what does this bit of obfuscated code do. So this is the kind of thing that you would get from ProGuard R8 or the default Flutter obfuscation. So what do you think that this code does? So we see we've renamed all of the methods, but did that help? So we can see exactly what this does because the strings are still there. Even the control flow looks like the original code. There is some maybe license check here. Maybe B is like a check of the license, and if that fails, then you show some message to the user. So normally in the default obfuscations, they're talking about name obfuscation only, not any further advanced obfuscations. So we can do a bit better than this. So this is more advanced obfuscations. We change the control flow. We maybe encrypt some strings, introduce some opaque predicates, and just make it much more difficult to understand what's going on. So I would say this is more difficult to understand than the previous example. But this kind of thing is also maybe not good enough. And why is that? Because, well, a lot of attacks, a lot of reverse engineers or attackers, they maybe don't even need to read that code. So maybe this code is difficult to read if you want to try to figure out what it's doing. But actually, if you just run your app and you attach a debugger to it, you can see what's happening at runtime, or you can inspect the memory, or you can change the behavior. You can hook some functions to change the behavior of something at runtime. So it doesn't matter then how much static obfuscation you have if the attacker doesn't need to actually understand that. So for example, if you have like a login button or a sign up button or something, you could hook that button to stop the application when that button is pressed, and then change the logic of what happens when that button is pressed. But So we have some good static protections. We have control flow, different kinds of obfuscation, string encryption, stuff like this. We also have some dynamic component to that. But is that good enough? Maybe not, because then given enough time, probably if someone can spend, say, weeks or months on reverse engineering your app, they can maybe still understand what's happening. They can maybe find the checks that you try to stop them with the dynamic attacks. So then the solution to this is to reset the clock every time you make a build. And the point here is to make an imbalance between you as the developer of the app and the attacker. So for you, it's relatively cheap to make a build. But for the attacker, if they have to spend weeks figuring out what your app is doing, how to reverse engineer the app, how it works, if that takes weeks and you can make a build relatively cheaply, then every time you make a build, you reset the protections, they have to start from scratch again. So if we then think about the security architecture of the app now, I think we can, if you think more about the client-side security, you can start pushing the security boundary further towards the user, including the app in your security strategy and boundary. Your servers are fully under your control, but your client app can also be under some of your control as well. So I want to leave you with one fact. This is based on our own monitoring data from live apps, real-world apps, that 1 day passes between the release of an app and the first dynamic attack on an app. So thank you there.